Welcome back to the Deep Dive. Today, we are steering directly into, well, the future of how we talk to AI. We're going to stop treating large language models like these magic black boxes and start seeing them as reasoning engines that we can actually control.
Yeah.
We're getting into some really advanced prompt engineering, and it's probably the highest leverage thing you can do with an LLM. It's the cheapest, fastest way to completely change what you get out of it. It really is the steering wheel for the model. Just these tiny little adjustments can shift everything.
That steering wheel analogy is, I think, perfect because it grounds us in what we're actually doing. You're not changing the model itself, right? The petabytes of data it learned from.
The core knowledge is still there.
Exactly. You're just changing the instructions. And that is powerful enough to change, well, everything about how it uses that knowledge. A good prompt, a really good prompt, helps it do 4 things. Think step by step, follow rules, stay focused, and maybe the most important part, avoid those really shallow, lazy answers.
So our mission for this deep dive, we're looking at sources that say, for the really complex stuff, logic puzzles, multi-step problems, anything with strict rules, you need to go way beyond simple questions. We're going to explore 4 key techniques, 3 for reasoning and control, and then a really brilliant one for getting creativity back when models get, well, a little too safe.
Okay, so to kick things off, let's talk about the challenge. LLMs are, they're amazing at complex reasoning, math, logic, that kind of thing. But they often fail because they try to answer too quickly. They need a little help to think clearly before giving you the final response.
And that's where the most foundational technique comes from, right? Chain of thought or COT.
Right. It's the cornerstone of all of this. And the mechanism is, honestly, it's almost comically simple. Instead of just asking for the answer, you nudge it. You just ask it to reason step by step.
Yeah, and the sources have this great example. It's not just a party trick. Let's say you ask it something kind of tricky, like a cafeteria has 45 apples, some students eat a few, but they also bought 3 new boxes of 20 apples each. How many apples are left? If you just ask that directly, you might get a wrong number. It just takes a guess.
It does a single fast pass. But when you add that tiny little nudge at the end, let's think step by step. Everything changes. The model is forced to slow down. It says, okay, first, calculate total apples bought. That's 3 times 20, so 60. Then it figures out what's left. It works through the logic instead of just jumping to a conclusion.
It's like asking a student to show their work on a math test. Instead of just shouting out an answer, you unlock the actual reasoning.
Exactly. But there is a problem. Chain of thought is, at its core, an improvisation. If you run that same prompt 5 times, especially with a higher temperature setting.
So more randomness, more creativity.
Right. The reasoning path it takes might be different every single time. It's powerful, but it's not consistent.
Okay, so we need something that can handle that variation, but with some kind of quality control, which I guess brings us to self-consistency.
Precisely. Self-consistency basically says, okay, let's embrace the noise. Instead of relying on one COT path, you ask the LLM to generate, say, 5 or 10 different reasoning paths for the same problem. Then you just look at all the final answers and pick the one that shows up the most. Majority vote.
So it's a brute force approach. Like, you get 10 people to solve a problem, you don't check their work, you just trust the answer that 6 of them landed on.
That's the perfect way to put it. And that's its strength and its weakness. It's really robust for getting the right final answer because it averages out the random errors. But, and this is the key thing, it doesn't care about the quality of the reasoning. If 9 of those paths are total nonsense but happen to get the right answer by luck, self-consistency says, great, that's the one. It only cares about the output.
Which sets the stage perfectly for the next step up. Tree of thoughts, or TOT. Self-consistency is about varying the final answer, but TOT is about varying the reasoning steps along the way.
Exactly. TOT is fascinating because it's basically a search algorithm. Think of it like chess. At every step of a problem, the model looks ahead and explores multiple possible next moves. Those are the branches of the tree.
And it doesn't just let those branches grow wild.
No, absolutely not. That would be a huge waste of compute. TOT uses another process, maybe another prompt, to evaluate each branch as it's created. It asks, is this step getting me closer to a solution, or is it a dead end? It then prunes the bad paths and only keeps exploring the promising ones.
So instead of 10 full, possibly flawed answers, it generates maybe 3 or 4 possible next steps, checks them, picks the best one, and then repeats that process. That has to be way more computationally expensive.
Oh, dramatically more. But you get what you pay for. That cost translates directly into much, much better performance on tasks that need deep planning. TOT turns the model from just a thinker into a real strategist.
Okay, so that covers how to make the model a better, more deliberate reasoner. But CAT, TT, they still depend on this sort of free-form internal monologue. And the sources point out a huge problem with that. It just completely breaks down in the real world with long, rule-heavy conversations.
This is the agent failure mode. I think we've all been there. You spend hours writing this perfect 2,000-word system prompt for a customer service agent. Never promise a discount, only use approved language. And it starts out great. But 5 messages later, the context is huge, the model's drifting, it's forgotten the rules, and suddenly it's offering a full refund and a gift basket.
It's the problem of uncontrolled reasoning. The model might be smart, but it doesn't have the memory or the discipline to constantly check a long list of rules. So how do you force it to be a good employee instead of a freewheeling philosopher?
You enforce structure.
Yeah.
And that's where attentive reasoning queries, or ARQ, come in. The idea is simple but powerful. You just get rid of the freeform inner monologue entirely. You force the LLM to think using a rigid, checkable data structure at every single turn.
Okay, so how does that work in practice? How do you impose that structure?
It's all encoded in a data object, usually a JSON schema, that the model has to fill out before it's allowed to generate its response to the user. So instead of thinking, I think maybe I should offer a refund, it has to answer specific, targeted questions inside that JSON.
So what are some of those keys? What is it forced to answer?
Before any decision, it has to fill out fields like current context, so what's happening right now, then active guideline, which specific rule number applies here, then require tool, do I need to call an API, and finally, next step, what is the exact action I'm taking?
Wow, so you're building this self-correcting internal checklist. It's forcing compliance. Let's go back to that refund example. With COT, you just see the bad final answer. With ARQ, what would you see?
This is the beauty of it, auditable reasoning. If the agent makes a mistake, you can look at the JSON it generated for that turn and see exactly where it went wrong. You might see that for the active guideline key, it cited policy 3. Discounts, when it should have cited policy 4, no refunds, you can pinpoint the failure. You just can't get that from a big block of text.
So it's doing 2 critical things, especially for enterprise use. It's constantly reminding the LLM of the rules mid-conversation, keeping it aligned, and the reasoning is completely auditable. Structure as compliance.
And the data backs it up. The sources pointed to tests across 87 different scenarios. Direct responses were about 81.5% successful. Standard COTI got that up to 86.1%. But ARQ, with its forced structure, hit 90.2%. That 4-point jump is absolutely massive when you're talking about safety or compliance.
And people are using this now in frameworks like Parlance, so it really confirms this idea. In any high-stakes, multi-turn scenario, structure always wins over improvisation. All right, we've talked a lot about control, about structure, but now let's flip to the opposite problem, creativity. Because if you align these models too much, they get boring. They give the same safe, predictable answers over and over.
Right. This is the paradox of mode collapse. It's a huge issue. The very processes we use to make models helpful and safe, like reinforcement learning from human feedback or RLHF, they work, but they have this unintended side effect of just crushing output diversity. They favor a really narrow set of stereotypical answers.
So why does making a model safer also make it more boring? What's the connection?
It all comes down to the human preference data used in that RLHF process. The human labelers who are ranking the model's outputs have a hidden cognitive bias. It's called typicality bias.
Typicality bias. Sounds like something out of a psychology textbook.
It is. It's this well-documented phenomenon where people subconsciously prefer things that are familiar, fluent, and predictable. So when human raters are looking at 2 good answers, they tend to give a higher score to the one that feels more common or safe, even if the other one is more creative or interesting.
Ah, I see. So the model learns that bias. It learns that predictable answers get a higher reward. So it aggressively tunes its probabilities to favor those safe, common answers, and it pushes down all the more unusual creative stuff it learned during pre-training.
Exactly. You end up with an LLM that has 2 personalities, the original, super creative, pre-trained one, and then this heavily filtered, safety-focused, predictable one that sits on top. And when you ask a normal question, that predictable personality just takes over by default.
So we need a way to bypass that safe personality and get back to the creative core, but without having to retrain the whole model. And this brings us to the last technique, verbalized sampling, or VSS.
Verbalized sampling is just so clever. It's like a mental switch for the model. If you just ask directly, write a unique metaphor about space, the safe, aligned personality kicks in and says, okay, the safest, most common metaphor is X.
But the VS prompt changes the nature of the request. You're not asking for one answer anymore. You're asking for a distribution.
Right. You're forcing it out of that single answer mode. The VS prompt would be something like, generate 5 possible responses with their corresponding probabilities, then write me a unique metaphor about space. Just by forcing it to calculate and state the probabilities for multiple different outcomes, you're making it access that broader set of ideas that's still in its core weights. It has to consider the probability of the boring answer and the more unusual ones.
It's like you're making the safe personality admit that other riskier options exist. And that's what lets the more diverse answers come through.
That's the mechanism, precisely. And the results are pretty stark. The experiments showed that using verbalized sampling boosted output diversity by 1.6 to 2.1 times, and did that while keeping the quality just as high or sometimes even improving it. It's a lightweight hack to unlock the model's full creative power.
That was an incredible tour of LLM control. We started with the simple nudge of chain of thought, saw it grow into the strategic search of tree of thoughts, and then realized for real-world tasks, we need the rigid structure of attentive reasoning queries.
And then, when all that structure gets a bit too restrictive, we saw how verbalized sampling acts as this training-free mental switch to get all that lost diversity back. It really shows that mastering these models isn't about magic words. It's about understanding and controlling their internal thought process.
So what does this mean for you, the listener, as you're building your own systems, your own agents, or creative tools?
We've kind of set up a bit of a dichotomy, haven't we? In high-stakes situations where rules are everything, structured thinking like ARQ is the clear winner over freeform improvisation. But for creative tasks, that freeform distribution you get with VS is what you want. So this leads to the big question you have to ask yourself. When you're designing any interaction with an AI, how do you decide if you need maximal control and structure, where precision is everything, or maximal exploratory diversity, where novelty is the ultimate prize?